Hey guys, thanks for stopping back to Pete's Garage. Now, we're going to start putting this engine back together for this 1962 Studebaker 289, and I'm going to do it in a couple different segments. We'll do a short block, then the long block, just so we can split it up. Now, before we get started, I want to answer a question that I get asked quite often is, do you need to use an assembly lube when you put your engine back together? The answer is no, not really. You really don't have to. Can you? Sure you can. And I use them all the time. I use all kinds of assembly lubes. You might get them from the cam manufacturers. Crane makes them. This is a Stay Lube. It's an engine assembly lube. It's got moly and graphite in it. So I use this occasionally, and this is almost all gone, so yes, I do use it. And on an engine like this, or if you're rebuilding an engine and you're going to use it relatively soon, start it up, and by relatively soon I mean, let's say 2-3 months or less. If you're rebuilding an engine and you're going to use it relatively quickly, 3 months or less, you can put it together using the same engine oil that you're going to use when you run it. The reason you use assembly lubes is to supplement the lubrication that's missing from basic oils upon initial startup. And most oils, regular conventional oils you buy, like in regular Castrol, whatever you buy, those oils have been stripped of some of their ingredients to make them more friendly to the environment. So they're missing some of the ingredients that would help on startup or break-in of your engine. And it's especially important when you, or for flat tappet or roller cams, when you're trying to break in the engine parts. So the lubrication is very important at initial startup for the bearings and the roller rockers, all those parts, the parts that touch and rub together. So that is when break-in and startup is most important for lubrication. So if you're not going to be starting it for a while, you're just putting an engine together, you can use an assembly lube, or you can use an oil. And the oil I'm going to be using for this is a 10W40 oil. What I use is a Brad Penn. It's a Penn grade #1. It's an SAE 10W40 oil. This oil I use for rebuilding engines because I'm going to start it up, and I use it for break-in because this oil has zinc and phosphorus added back into it. Now this isn't the kind of oil you would buy to do an oil change. You could, but it's $7.50 a quart. But this oil has got the ingredients back in it that will aid on break-in, reducing friction at startup, and that first 60 seconds when you start it up is the most critical because all the parts are brand new. They're going to be at maximum friction, and you want to make sure that you have something on there that's going to attach to the parts, and we can get into all the metallurgy of it, but that really don't need to get into that. The basic question is, do you need to use an assembly lube? The answer is yes, you can. But remember, if you use an assembly lube, and some of the stuff is pretty thick, what do you got, the lizard oils and all that kind of stuff that's really thick, you got to remember when you start your engine up, that stuff will be there until the oil gets there, but once the oil gets there, it's going to flush it all out. And the question is, what happens to all that stuff after the oil goes through the engine? And the answer is it sits in the oil pan. And you have to change the oil relatively soon because all that stuff will sit there and clog up and gunk up your engine. Whereas if you're going to start it, run it, and break it in right away, you can use something like this that has the phosphorus and the zinc in it. And this is considered a high-performance oil, like a racing engine oil. It's called the green oil, although it's not green for the environment, but it's designed for historic muscle cars, classic cars, race cars, that kind of thing, and it's got those additives in it. And I use this to build the engine with because it cleans up better. You don't have to worry about it being stuck throughout the entire engine. And once I do the first oil change, it's just a regular 1040 oil that will be a little bit left behind, but this is basically what the engine is going to run on. So I'm not worried about letting it sit for months and months and months. We're going to build this thing and start it up right away. So that was a long way of saying, no, you don't have to use an assembly lube. You can actually use the oil that you're going to run the engine on. And in the factory, when engines are built, even on brand new cars, brand new engines that have very tight tolerances that are in microns, they just use the engine oil that's going to go in the engine. There's no break-in oil. They don't use assembly lubes. They don't use anything. They just put oil on the parts that's going to be in the engine. And some of those engines could sit maybe 3 to 4 months before they even start. So the factories don't even use an assembly lube. But I'm not going to say don't. I'm not going to say you can't. There are times when I do and there's times when I don't. But for this case, when I'm going to start it up soon, I'm just going to be using the Brad Penn engine oil 1040 that has zinc and phosphorus in it. So let's start building this short block. Alright, let's start with the main bearings. We're going to start with the front of the engine. The front of the engine is up this way, back engine back there, okay? Now the thrust bearing, the front bearing is a thrust bearing, and there's a notch, a lock notch on the thrust bearing, and it can only go in there one way. Now, usually I would just go in and throw these bearings in there, but I'm going to tell you something you want to check. For your thrust bearing, these are the thrust faces right here. This face and this face are the thrust faces, and the thickness of this thrust bearing is actually really important. And what I would suggest is that you take a micrometer and measure these thrust faces, because I bought a set of bearings and they were way off. By way off, I mean there was run out. On one side, the bearing was 3.5 thousandths thicker than it was on the back. So if you take your micrometer and just check, so here we got 101 thousandths. Take it off and check in the middle. Just 102. And then check on the other end, 101.5. And then do the same for the other side, 101.5. Check in the middle, 100.5. And on the end, 101.5. So check the thrust surfaces, the thickness, because like I said, I bought a set of bearings, and from end to end, the one side was off by 3.5 thousandths, which is no good, so I had to get a new set of bearings. So check your bearings. Also, I'm wearing gloves so I don't get any of the oil from my hands on the bearing. Now, you set your bearing into place, make sure the lock notch is in. You simply press it into place like that. Now, before I did that, let me pull that back out. Before I did that, I thoroughly blew out the oil holes. These oil holes that go all the way down the engine are critical. So I blew out all the oil holes, blew out all the threads, wiped them all down with lacquer thinner, make sure there was no oil anywhere on the bearing surface. So you just put your bearings in the lock notch, and then we'll work our way down to the back. And I'll make my way down with the rest of the bearings. Yeah, that's Shelby snoring in the background. Okay. And the rear bearing. And now I'm going to set my rear seal in place. The rear seal looks like this. Okay. And you can see there is a difference. You see this kind of flange here, this rubber flange? That faces inside the engine, so this part faces inside, and that part faces outside. It goes in there just like this. Okay. Now, as I said before, I use the Brad Penn oil, and I'm just going to put some oil on my bearings. Just to lube them up a little bit. We'll talk about this thrust bearing and setting our thrust clearances after I put the crank in. Okay, now before I set the crank in, let's go set it up with the plate on the back that connects to the torque converter. Before I put the crankshaft in, I want to put this plate on. This is the plate that connects to the torque converter or the flywheel. And these are the bolts that go in there. If you can see, the bolts have a flat. And the flat on that bolt faces in towards the crank. So when you put this in here, you line it up with the flat spot on the inside of the crank, and it snugs right up against there. See how it goes nice and snug against? And you put this on, these are 9/16. So I'm going to tighten these all up, and then we'll put the crank in. Now I can gently set my crank into place. It spins nice and free. Now I'm going to check my crankshaft end play, and the spec is 3 to 6 thousandths, and the gap I'm trying to check is right in here. Okay, in between the crankshaft the face of the crank, the thrust face, and the thrust bearing. And in order to do that, I have, this is the part that goes on the crank to set that. And you put that in, and I'm going to push the crank all the way this way. And what I'm trying to do is I'm trying to get the front, I'm trying to get this part of the crankshaft, this face right here, even with the front face of this thrust bearing. So if I push it backwards a little bit, and if I pull it up real slow, make sure that it's flat with that face, and I'm pushing this against the face, I'm going to measure. Now, I should have at least 3, and I do have the 3. Okay, that goes in. I'm sorry, that's 6. I should have at least 5. Okay, the 5 goes right in. See how the 5 goes right in? 5 goes in. Here's the 6. It's a little sticky, and just to make sure, I'm going to check it with a 7. Here's a 7, and the 7 won't go in. So the spec is 3 to 5 thousandths, or 3 to 6, I'm sorry. The 5 goes in, the 6, no. So I'm right at 5 thousandths on my crankshaft end plate, which is right within spec. Now, if you were not in spec, and let's say it was too tight, you put a shim in here, and these shims would look like this. It's a shim, and you'd put the shim on here, and what that would do is would bring the crank closer to the front of the bearing. But since it's 5 thousandths without any shims, I don't need to put any shims in. That's the benefit of having the machine shop grind the crankshaft to the crank, or grind the crank to the bearing, to the block, and they match it all up. It's set to 5 thousandths, right in the high end of the thrust clearance, and I don't have to do anything. No shims are needed for this. So now that everything is moving freely, I checked my front gap. I can start putting my main bearing caps on, and you need to check your main clearance. The main clearance is supposed to be about 5/10 up to about 3.5 thousandths. Now, I don't have to do that because if you recall, when I had this block machined, or when I had these parts machined, the machine shop clamped up the main bearings. They put the caps on, they clamped it up, they measured the inside diameter of all the journals, and they ground the crank and polished it to within 2 thousandths. So I know that all my clearances on all my main caps are going to be, the clearance on all the mains is going to be 2 thousandths. So all I'll do is put a light coat of oil on all my bearing caps and put them all in place. And if you put those on there, all you have to do is put them on, set them in place, and just a light tap will put them in place, and I'll put the rest of them in. Alright, now I'm going to put the rear main cap on and the rear bearing. And a couple things to notice. First of all, the caps can only go on one direction, and if you lost track, the stamping number on the top of the cap, so there's going to be a stamp number on there, you'll be able to read that from the back of the engine. So the back of the engine, all the numbers are readable. Now, we'll put this rear main bearing cap on, and if you notice, the seal fits in this groove here, and it's got these nice little tabs on it, so when you set this bearing, or I'm sorry, set the seal in, the rear seal in, see how these tabs have to line up with these grooves. And since it's a rubber part, they're going to want to move around. So when you put those in place, you want to make sure they line up with the grooves. You don't want it like that. You don't want to have that coming out. So that's got to line up with the groove. Just like that. And it should stay there. And as long as you're careful and you carefully flip it over, got a light coating of oil on there, and gently set it in place, those little things will still line up, and I can tap it in place. Now, the little parts, if you look way down in there, you can see the part that's down there. That is going to get trimmed off, and these cork fillers go in place on the bottom. So after I torque down the main caps, I'll trim off that little piece inside. So now with all the caps on, I can torque it down. The spec is 85 to 95 foot-pounds, and I'll be happy right at 90. Start in the middle, work towards the outside. So crank down the middle and work towards the outside. we'll flip it over and put some pistons in. Okay, before we can put our pistons in or we put the rings on, we have to actually gap the rings and make sure our gap is correct for the top ring, the compression ring, then the X ring, and then the oil rings. Now, the advantage of having your cylinder bored out to a standard size and getting a standard oversized piston is that you can buy a standard ring. And when you buy a standard ring, you won't have to worry about grinding the gap. The gap should come preset. Now, I'm using a Molyroom chrome Moly rings instead of the standard iron ring that came in the engine. The difference is the chrome Moly ring is designed to last longer, more wear resistance because of chrome Moly in the steel. It will lubricate better and it'll seat better than just your standard iron ring. The iron ring is going to wear faster, and it may be tough to see, but you can, the cross section of the ring, you can see there's like a little chamfer there. So the iron ring goes on in a certain direction. So what I'm going to do is I want to check the gap, and the gap for the top ring is 12 to 20 thousandths, and you have to get the ring in here, and I want to check this gap, and in order to get this ring in here straight, and it's got to be in a little bit because there's a taper in the cylinder, I'm going to take a piston. I'm just taking one of my pistons, and I'm going to put my oil ring in here. First I'm going to put the oil wiper on the piston like that, and now I'll put my upper and lower rail on. And what you want to do is, if you're doing this yourself, you want to sit the, you can see I'm going to sit the lower rail in there, and I'm going to sort of work it around. The one thing I'm going to be careful is this end of the ring right here, I'm not going to drag it across the face. I'm not just going to wheel it around here, because if it drags on there, it will scratch the face. So I'm going to bring this around, and as I do, I'm going to lift up. I'm going to lift up on the ring. I'm going to pick it up. I'm going to lift it like that. Lift it over my wiper and sit it in place like that. That way I don't have to worry about any scratches, okay? And of course, there. Okay, now that seat's on there just like that. Now I can put my bottom rail, or I'm sorry, my top oil rail on, and I'll just bring it around and lift it up so I don't drag it across the face of the piston. So now I got that in there. What I'm going to do is I'm going to push this ring into the cylinder using my oil rings as a stop. That way I'll get it in there straight, and I'll be sure that the ring is sitting in there even and it's not on an angle. So now I can come in here and I can check the gap. The gap is right here, and it's got to be 12 to 20 thousandths. So let's just throw the 12 in there to make sure we got 12. And yep, got the 12. Let's make a jump up here to 15. See if there's 15. Got 15. I'll go to 17. Okay, 17 won't. 17 just barely fits. Can't get it in there all the way, so it's 17, 16. So, okay, the 16 goes in there. So my gap on my top ring is 16 thousandths, which is within spec. The spec is 12 to 20, so it's on the low side, which is great. Now I'm going to check the rings for each cylinder all the way through, but since for each cylinder, so I'll take each ring that I'm going to use in that cylinder, I'll check it in each cylinder to make sure that the gap is correct. I'll also do that with the second ring. The gap on the second ring is 8 to 16 thousandths, so I'll do that with the rings, and then I will put them on. Now I've already done the second ring for this one, so I'm going to show you putting the rings on. Let me take this ring out of the cylinder gently. Set it off to the side. Now, when you put your rings on, they can be directional, meaning they should go on a certain way. They usually have a mark on them, and this one does not have a mark. Let me set this down for a second. Went to grab one of the iron rings. Now, if the ring has a dot on it, and I don't know if you can see that. See if I can show you that. There's a dot right here. If your rings have a dot, that dot faces up. I'm going to set that aside so I don't confuse my iron ring with my regular rings. If the ring has no dot, now this is a second ring, it does not have a dot on there. There is no dot. Oh wait, there is a dot. You gotta check carefully. So see, there is a dot there. It was covered up with some of the coating. I don't know if you can see that. Let me try and get that. See that dot? That dot right there? That dot has to go up. So I have my piston, okay, and I'm gonna put this on here, but I'm not gonna do it by hand. I'm not gonna fold it around. I'm gonna use my piston ring pliers like this, and I'm gonna put the ring in my pliers like that. So I'm going to put my piston ring, I'm going to do this carefully, put it in the pliers, expand it, I'm going to hold it so I don't drop it. I'm going to lower it down to my second gap and put my second ring in. Now my top ring, my chrome moly ring does not have a dot and it doesn't have a bevel, so it can go on in any direction. I'll do the same thing with the top ring. Spread it out with my pliers, get it over the ring just enough, and there we go. Now it's important to use pliers because if you spread that ring too much you can crack it, and if you crack it the rings are scrap, and you also have to be careful not to drop them, because if you drop them you'll nick the ring and you'll have to get a new ring. So this is number one. Let me get this ready. I'll turn the block over and we'll put the piston in. Now one thing before you install your pistons, if you forgot which way you took them out and you don't remember which way faces forward, you take a look at your rod here and you'll see one side has a bevel that goes all the way around. See that bevel? And the other side does not have a bevel. The side with the bevel faces the crankshaft. The side that's flat faces the other rod. So that's how you know which way the piston goes in. So now what I'm going to do is I'm going to take my cap off, set it aside, and what I'm going to do is I'm going to lubricate my bore, and then I can slide my piston in. So now my bore is lubed. I got some lube on the bearing surface and my rod bearing, and now what I'm going to do is I'm going to clock the rings, and clocking the rings is simply putting them around at different positions so the gap is not in the same spot. And if you've done this a bunch of times, you can do it fairly quickly, and you get used to knowing how to do it. So clocking the rings is just putting them at different positions, usually like a third away out of the way. If you don't know what to do, just look at the instructions on your rings and it'll tell you. So now I'm looking at my bevel. I'm going to slide this, and I'm going to lay this in here gently in my bore, like that. I'm just going to sit it there, because I have to put my piston ring compressor on here. I'll lift it up just a little bit, and the way this works is you just tighten this down. And I want to lift this up just so the piston is inside of the ring compressor. It's a little tough to do this while you're filming, believe it or not. So let's set that on there. Okay, now I'm going to crank down on my ring compressor, and you don't have to crank the hell out of it. And what I want to do is I want to make sure that the piston, first of all, line up on the back. It's lined up with the crank, and I have the crank turned all the way so that the pin is furthest away. I don't want to hit the rod or any of the bolts to hit the pin, because it'll nick it and I'll ruin the crank. So now I have it straight, and I want to tap this in, and you want to try, you can tap it a bunch of times like this. You want to make sure that the actual ring compressor stays square to the cylinder, because if one of the rings pops out you'll have to start all over again. So you want to try and get it in one shot if you can, but if not, there you go. Piston's in. Now let's go to the other side. We'll take a look at well, that was the ring compressor. It wasn't a part. Let's go to the other side and we'll put the rod on. Okay, I have my cap ready with some oil on it. I have my beveled surface so I know which way it goes on. I'm just going to sit it up here off to the side, And I'm going to reach underneath here, and I'm going to grab the rod, and I'm going to guide it over the pin, and I'm going to push down very gently, and I'm going to grab my mallet so I can do this without doing it too quickly. I don't want to hit one of these bolts on that pin, you're going to cause a nick. So you want to hit the pistons down very gently, guide it over the pin. And there we go. Sitting on the rod now, sitting on the pin. And take my cap, and again the cap goes with the bevel side facing the crank, just like this. And cap, hold it on there so it doesn't fall. See, I dropped a nut because of that pin. Now it's going to stay there. And I'll put the nuts on, just to hold it in place. Bottom one on. Now I'm going to do these finger tight. And I'm going to go all the way around. I'm going to put all the pistons in and do it just finger tight. Just to make sure that when I turn the engine, and I have the bolt in the front here, and I'm going to turn it just to make sure that that piston moves up and down freely, and it moves up and down nice and free. So now I'll put the second piston in, number 2, and I'll continue on down the line. So I'll do the same basic procedure for all the pistons. Check the gap, install the rings, oil up the cylinder, oil up the bearing, put the piston in, oil the cap, oil the pin on the crank, put it on, and hand tighten the nut on the cap, and then turn it around just to make sure that that piston is in right. And the reason you do that is because as you go down and put each piston in, if you turn the engine over and you have all of a sudden have resistance, you know exactly which piston's giving you trouble, so you can take it back out and look at it rather than put it all together, turn and go, boy, I wonder which one it is. So do one at a time, turn it over, and you'll be successful. So let me continue with that, and we'll come back and I'll show you how it looks when it's all done. There's one thing I wanted to show you with your connecting rod bolts, the cap bolts. Now you see when I push this down, you see how flush that fits? If I take this and turn this around 180 degrees, you see how that doesn't fit right? This is actually it's got a little chamfer on it, so that when it's sitting in there, it sits in there flush. Okay, so make sure that when you put your caps on, the cap screws are not 180 degrees out. Make sure they're facing the right way so they fit nice and flat. That way, when you put your cap on, and you hold it on, and you carefully put it on. See how nice and flat that is? Now when I put the nut on, when it draws down, see how it's nice and flat? That's important. Alright, one last check. All 8 pistons installed. One last check before I turn it over and torque down all my cap screws. Yeah. Nice and smooth. Now we can torque down the cap screws. And the torque spec on the rods, 28 to 32. I got them all just about to 30, 31. Give it a quick check. It's all still nice and loose. So, one last thing here. I'll pick up the camera here. I'm going to show you something that's kind of important. On this particular engine, you know the pinch bolts that go in that were put on for the pistons were put on with those pinch bolts, right? You can see in there the pinch bolt that goes on the piston. So for 1, 3, 5, and 7, the pinch bolt, when you put it in, the pinch bolt should face the outside of the engine. And on 2, 4, and 6, the pinch bolt will face the inside of the engine. See the pinch bolt down in there? So on these 2, 4, 6, and 8, the pinch bolt faces the inside. 1, 3, 5, 7, pinch bolt faces the outside. 2, 4, and 6, pinch bolt faces the inside. So there you have it, guys, installation of the crankshaft and the pistons. Next video, we'll do the installation of the camshaft, degree the cam, set the timing with the gears in the front, and button up the front end with the crankshaft. Thanks for stopping by Pete's Garage.